Hello, welcome to the lecture of engineering mechanics. Today we'll be covering centroid and moment of inertia. It is very easy topics, so you just need some attention so that if you understand this concept, it is very easy. The question, if question will come on this topic, it will definitely give mark to you. Okay, so we'll start from centroid, then we'll go for moment of inertia. These are the outline I'll be covering. Okay, let's go to the topic. So before starting centroid, we should know three things: what is center of gravity, what is center of mass, what is centroid. These are the common things. There is a small difference between all these things. You will see these are alternative terms used everywhere. Okay, you should know what are these, the actual meaning of all these. So I'm taking some example. Okay, see this one, then I will take. Okay, see in this one, if I'll draw, it is a 3D object. Okay, so what I will draw, so is this one is a 2D object. Actual object is this, we are seeing the side view, so it is a 2D, that is a planar object. Okay, here is the 3D object. See what I'm saying, I want to discuss about center of gravity, center of mass and centroid. See, this is an object. Okay, this is an object. In this, there are several particles containing in this object. Okay, there are number of particles in everywhere. There are number of particles. What will happen? Every particle have some masses. Okay, each and every particle have some masses. Suppose m1, m2, m3, like there are infinity number of masses. So what center of mass is saying, center of mass, okay, there are number of masses present in this object because the object is consist of n number of small tiny particle. So in that case, the mass center we are considering, it is not actual case is like this. The object is like containing number of masses, so we are considering center of mass, it is a point. Okay, on the object itself, so its center of mass, we are considering center of mass is a point where all the mass are concentrated. Suppose there are number of n number of mass, m1, m2, mn up to mn. So we are saying all the mass will be at a single place, at a single point acting. In actual, it is in different position of the object, but we are saying at a point the all the mass will be concentrated. So I'm saying center of mass means mass center. Okay, mass center, what it is, all the mass, we are assuming, in reality this is the situation. In reality, all the masses concentrated, all the masses concentrated on the center of mass. Okay, see, in the starting of engineering mechanics, I have said you that one assumption. The first assumption I have said you that in engineering mechanics, whatever object we are dealing, that's a rigid body. And the second assumption was, I have not said at that time. Now I'm saying the second assumption in engineering mechanics, that distributed force system can be considered as a single force, single concentric force. Whenever you have a number of force acting on an object, okay, number of distributed force, they are parallel. So we can replace these all the force with a single resultant force. Okay, this is the actually the assumption of engineering mechanics. It will apply everywhere on the engineering mechanics. So this is center of mass. What is center of gravity? See, gravity, you know, the weight is the force, pulling force by the earth towards its center, to its any mass, any object having some mass. Suppose this is the object having n number of masses. Okay, everywhere there are mass. So what is happening? Center, what will try to do? Center will try to apply the weight on each and every mass. Okay, each and every mass the center will try to apply. Suppose m1, so m1g, m2g, m3g, mg4, these are the weight, all the weight on each and every particle. So center of gravity, what? Center of gravity simply, it is the weight center. We have number of weight, we are considering that weight is acting at a single point. There are, in reality there are number of weight, but we are saying weight center. That means we are considering or assuming all the weight of the object acts at the CG. Okay, you got idea about what is mass center, what is center of mass and center of gravity. So suppose, and this center of mass and center of gravity actually taken at the center of the object. Okay, at the center of the object, at the 3D object, the whatever, this is a volume, so volume having and center. Suppose I will say this is a face, see, this one is a plane, this one is a plane. Getting my point? So I'll take the center here, this is a plane, I'll take center here, every plane having some center, so we'll join all the center and all the center will meet at a single point. This is the point, this is the center of the volume. Okay, that's called, that is the location of center of mass and center of gravity. See, center of mass is same everywhere, whether you are in the earth or in any other planet, because object having mass, you cannot change its mass. But the gravity force, where m1, m1g, m2g, m3g, these are the weight, its value will change if the object will be going to moon. Okay, so it's a relative quantity with respect to location. Okay, because weight, we are talking about weight, it's depend upon g. Okay, so suppose this is the length and this is the length, this is the height, and here is the thickness. If I will do thickness is nearly equal to 0, like a thin sheet of metal. Okay, in that case what will happen? It will be treated as a 2D object. Okay, it's a plane, just like a thin plate. Okay, so I'm taking a rectangular plate. What I'm saying, it is also consist of different mass, but see, we don't have any volume on that. So the center of this area is taken as what? If you talk about weight, there are weight acting. Okay, see, there here on the plate also there are some mass and weight, all these are acting everywhere in the downward direction. Getting my point? At every point there are small weight. What we will do, we will consider the weight at the center, this is the resultant weight. Suppose W1, W2, W3, there are, here is the capital W, the total weight acting at the CG of the 2D plane. Here is the CG or center of mass of the 3D object. Okay, whenever you are taking thickness is equal to 0, the object, 3D object, we can say it is a 2D. So in this case, this is the CG. Is there any mass of all the object? Okay, center of gravity is nearly equal to, I will write any object, center of gravity is nearly equal to center of mass. It's almost same. Why I am saying almost same? Because all the objects are in the earth's surface, you are getting equal amount of weight. So the location of the center of mass and center of gravity is same. Okay, here you see there are, these are the mass center, like center of gravity and center of these two, center of gravity and center of sorry, center of gravity and center of mass, these two always lie on the plane, lies on the plane or object. If you are talking about plane, it will lie on the plane. If you are talking about on the object, it will be on the object, it will lie. But centroid, it may lie or may not lie. This is a special thing, okay, about centroid. It can lie on the object or plane. It centroid will not be on the object because centroid is a area related concept. So it will be inside the area or outside the area. What is centroid? I'm saying, see, centroid. So centroid, simply centroid means geometric centroid, geometric center of the plane. See, area, I'm talking about area, okay, that's why plane. So geometric center of plane or any area. So in this topic I will be discussing how to calculate centroid of different plane figure, okay, like rectangle, triangle, square. Then we will talk about circle. All these, whatever geometrical figure we have, we will be discussing centroid of all that, okay. So it is geometric center means the small area. If I'll take small area over here, small area, I'm saying the same concept with the same principle of center of gravity and center of mass. We are considering that the total area, see, area is not a vector quantity. Here weight was a vector quantity, so there are number of weight. I'm considering the resultant weight acting at Cg or Cm, okay. But here area is not a vector quantity, so still I'm considering the same principle. So I'm saying this, all the area will be concentrated at a single point. This is an assumption or a hypothetical thing. So we are assuming that all the area in the object, if you divide the area into n number of object, suppose this is the area, I'll cut it to different. So I'll say this is the point where I'm considering all the area of this plane is considered, or the I mean to say A1, A2, A3, whatever number of area are there, they are concentrated at a single point. That's called centroid, okay. So this is the geometric center. It can lie on the plane, it can lie on the plane or outside the plane, okay. This is all about the basics of centroid. Now you got center of mass is same as center of gravity. Here I'm writing, okay, center of gravity is nearly same as center of mass because it is coinciding at a single point. Here this is nothing but the center of gravity, or we can say the centroid. That is, centroid means area center. The whole area is concentrated at this single point, and the center of gravity means whole weight of the object is is concentrated at this single point. So for a 2D plane, the center of gravity Cg and the centroid are the same. Getting my point? The center of gravity and Cg, these are a single point. These two are coinciding at a single point, at this point, okay. So now I will calculate for how to calculate this location of this center of gravity or centroid of a 3D object or a 2D object, okay. In the syllabus, our syllabus is restricted to 2D. We will be calculating center of gravity of the centroid or center of gravity of the 2D object, that is plane, okay. See, if you got this point, you can calculate the center of gravity of the 3D. How? It will lie on the same plane. If you extend this one inside the screen of this laptop, what will happen? At the t/2 location, the center of gravity will be present in the same line, okay, in the same line where the centroid was in the plane. Wherever the centroid in the plane, like A, B, C, D. This is the plane A, B, C, D. On the ABCD plane, this is the point where centroid lying. I will draw an axis which is parallel to all the four line along the thickness. So at t by 2 on this line, the centroid will act. So 3D object, no issue. If you can find for 2D, you can get the centroid of the 2D object as well. Okay. Now we'll go for the calculation. See, calculation of center of mass or center of centroid. Okay, or say CG, whatever you say, CG for 2D. Okay, calculation of coordinates. What is the location of the center of mass, which is equal to centroid, which is equal to center of gravity for a 2D plane. Getting my point? Now how we will calculate? See, I will calculate for the mass like center of gravity, where all the weight are concentrated on that object. Likewise, we can calculate for centroid taking area concentration. Okay. See the fundamental behind the derivation of this centroid. I'm taking two axes. Okay. Here is the axis, another axis. Again, I'm taking a circle like this. Okay, this is the object I'm taking. Here, actually it's a 3D object, I'm taking as 2D. Okay, so now I am slicing this object into number of parts. Okay, so what will happen? Here is the x-axis, here is the y-axis. Suppose this one is called A1, A2, likewise A2, A3, A4, A5, A6, A7, A8, A9. So these are the area. So all this area A2, A3, A4, A5 up to like this, and this portion of this object having mass M1, M2, M3, M4 like that. Okay. So what I'm saying, if I'll calculate the moment of, see, we have calculated the moment of force. Moment vector was equal to the force into perpendicular distance. Okay, this was the simple way for calculating moment of the force. Now I'm saying to calculate the moment of the weight or moment of the mass. Okay, so in that case, if I'll calculate the moment of mass, see, about this y-axis, suppose this is the number one object having mass m1. So this is at a distance of x1 from y-axis. Another is at a distance x2. Likewise, there are number of different mass at different distance from the y-axis. So if I will calculate the moment of masses or weight, moment of weight, so I'll be writing m1 x1 plus m2 x2 plus m3 x3 plus up to . Okay, these are the moment of the weight about y-axis. See, these are the moments which is equal to how much? These are the moment due to the first strip, the second strip, moment due to third strip, like this. I'm saying this for CG is a point. CG what? CG is a point where all the weight are acting. So this is the weight. Okay, this is the center of gravity. Suppose the distance of y-axis and center of gravity I'm taking at x bar. Okay, I'm taking here. So the moment due to this one, suppose the moment is like this. The total mass of the object is m1 plus m2 plus m3. Like I'm taking this, the sum of all the mass. Sum of all the mass is equal to m. Okay, small m is equal to m1, m2, m3. The summation of all the mass is equal to capital M. So mass into what will be the distance, the moment of the mass. Not I'm talking here, I'm taking moment of the mass. The location of CM, if I'll calculate the location of CM, which will be equal to location of center of gravity. Okay, This is the same thing. So I'm taking mass into the distance x bar. So this is the location, the coordinate x coordinate. Okay, suppose this is the point, that's called center of gravity of this plane. So it is having coordinate called x bar, y bar, suppose. So I can calculate x bar here. X bar is nothing but sum of the masses small m into small x, like 1 2 3 mi. I'll write just like this. Then in the divider, the capital M. Capital M nothing but the sum of mass. Okay, this is the formula. I can what is the meaning of this? M1 x1 plus M2 x2 plus up to like this. Okay. In the denominator we have M1 plus M2 plus M3 up to dot dot dot. Okay. So this is the coordinate, x coordinate of the centroid. Likewise, if you take the distance of these points like this, y1, y1, y2, if you take random distance like this, again you calculate the same concept. Y bar will be like sum of sum of my, okay, sum of my divided by sum of the mass. So similarly you will write m1 y1 m2 y2 plus up to dot 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 divided by the sum of the mass m1 plus m2. These are the concept behind how to calculate center of gravity. So once you got x bar, y bar, this is the coordinate, x coordinate of the centroid, y coordinate of the centroid. Okay, this is the location. Okay, once you got all these, so you got the centroid location. So this is the way how to calculate the location of center of gravity or center of mass. What you have said. See, you got whatever the idea behind all this. Now what I'm doing, I will be just writing the formula. These are the things don't required for the examination. We just need the formula. ମୁଁ ଆପଣମାନଙ୍କୁ ବୁଝୁଥିଲି ଯେ କେମିତି ମାନେ এই ସେଣ୍ଟ୍ରଏଡର ଭିତରେ କନସେପ୍ଟ କ'ଣ, ସେଣ୍ଟର ଅଫ ଗ୍ରାଭିଟିର ଲୋକେସନ୍ କେମିତି କ୍ୟାଲକୁଲେଟ୍ କରିବା, ସେଣ୍ଟ୍ରଏଡର ଲୋକେସନ୍ କେମିତି କ୍ୟାଲକୁଲେଟ୍ କରିବା, ନେକ୍ସଟ ୱିଲ୍ ସି. ଓକେ, ସୋ ହିୟର, so for center of mass, okay, we calculated for the center of mass, center of gravity or center of mass, the coordinates are like this. X bar is equal to m1 x1 plus m2 x2 plus up to dot dot divided by sum of the masses x, m1 plus m2 plus m3. So it can be written like this, sum of the mx divided by the sum of the mass. Getting my point? The y bar is equal to m1 y1 plus m2 y2. Simply आमे कौन गले ना सब जगह स्ट्रिप रो मोमेंट नहीं गले अबाउट x एक्सिस y एक्सिस. सो ये सब गोटे एक्सिस अबाउट रे निया जाए. सो हमर गोटे रेफरेंस एक्सिस नोचे ता अबाउट रे हमें सब जिंसो काढु. ठीक अछि, x1 y1 plus m3 y3 divided by sum of the masses, like similarly m1 m2 m3. So I can write this term as y bar is equal to sum of the my divided by the sum of the masses. Okay, this is the formula. Here is the formula. Okay, x bar is equal to sum of mx divided by the sum of mass. Once you got this idea how we are calculating the location of CG and CM, simply just we have taken the moment of the masses. Now we'll be talking about how to calculate centroid. Similarly, center of gravity कौन थिला ना जिते जाको वेट थिला सब गोटे पॉइंट रे कंसंट्रेट होतला. सेंटर ऑफ मास भी सेया, सब जगह मास गोटे जगह रे कंसंट्रेट होतला. सो हम सेंटर ऑफ मास रो लोकेशन काढ देले ए वे रे. मु कोन कोसी वर्तमान सेंट्रोइड, सेंट्रोइड कोन ना सब जगह एरिया गोटे पॉइंट रे कंसंट्रेट हो. सिमिलर वे रे जदी तमे काढिबो कोन हो, ए सपोज छोट छोट एरिया मुनेली a1 a2 a3 आमे नै थिले जिन लास्ट रे. सो y एक्सिस अबाउट रे काढिबी केमिति ना a1 into the distance moment of the area मु काढिबी हला by moment of the area 2D plane रो सेंट्रोइड लोकेशन बाहर. सेंट्रोइड पई भाई ए प्रथम स्ट्रिप रो धर x1 वाला डिस्टेंस सेकंड स्ट्रिप रो x2 वाला डिस्टेंस यार एरिया हला a1 into x1 plus a2 into x2 is equal to a3 into x3 likewise is equal to total area concentrated at this point. Suppose this is the point, this is the centroid having location suppose x bar y bar. Okay, so x bar is nothing but the distance like this. So total moment due to this area will be capital A into x bar. So I can write x bar is nothing but sum of the area a1 a into x divided by the sum of the area. Similarly you can calculate y bar is equal to sum of the ay divided by sum of the area. Getting my point? Similar formula, okay, for calculation of center of gravity or center of centroid. Whatever summation symbol I'm writing, I can also write as an integration, because the same thing, sum means integrating. I will take a small strip, then integrate over the total area, you will get the same result. Okay, here I can write like this: x bar is equal to integration of a into x divided by total A, capital A. Sorry, dA is the small area integration. That means you got total area. So ax, or we can say xdA, xdA, okay, divided by dA. This is by integration method I can calculate also. So finally concept आम कौन शिखले सेंट्रॉइड रो लोकेशन केमिति कैलकुलेट करिया गोटे फिगर रो x bar is equal to x1 sorry a1 x1 plus a2 x2 plus a3 x3 plus up to jete bhi area thibo divided by the sum of the area, like small area a1 plus a2 plus a3. ए formula बहुत important. y bar केमिति कैलकुलेट करिया ना a1 y1 plus a2 y2 plus a3 y3 up to divided by a1 plus a2 plus a3 up to suppose see यार मीनिंग कौन सेंट्रोइड फॉर्मूला रो ए दुटा जिनस तुमको मन रखार अच्छे, ठीक अच्छे ना, किसी ना सिंपली सम ऑफ ए एक्स divided by total area, sum of ay divided by total area. So it is centroid रो calculation. Suppose एमिति गोटे फिगर टे अछि, देखो ये गोटे एरिया अछि ता संगे आ गोटे एरिया कनेक्ट होइछि. मते वर्तमान मते मु ड्रा कली मु कहली तुमको ना ये गोटे सिंगल प्लेन एडी जगह रे किछ नै. सो एडा वाला गोटे एरिया आरो सेंट्रोइड तुम लोकेशन काढ दबो, ए सेंट्रोइड रो लोकेशन काढ दबो, a1 जानिचो a2 जानिचो, गोटे रेफरेंस एक्सिस धर एटा नेली मु रेफरेंस एक्सिस तार लेफ्ट साइड टा. ओके, ए अबाउट रे आंकर सब डिस्टेंस काढबी. सो एटा हला फर्स्ट एरिया रो सेंट्रोइड, एटा हला टोटल रो. सो टोटल ए एरिया रो सेंट्रोइड कोड लाई करियो, एटा एठी लाई करियोनी एठी लाई करियोनी, आंकर मझिरे कोड गोटे एठी कोड लाई करियो, ठीक अछि. कोठ भी लाई करियो तांकर टोटल केमिति कैलकुलेट करिया ना x बार करिया a एक्सिस रु y एक्सिस रु, y बार करिया ए x एक्सिस रु, ठीक अछि, x एक्सिस y एक्सिस. सो x बार काट दबा y बार काट दबा, हमें लोकेशन पाई जिबा टोटल कॉम्प्लेक्स फिगर. एमिति वे रे जेते भी कॉम्प्लेक्स फिगर थाए हमें सेंट्रोइड कैलकुलेट करियो. Now I will discuss some of the figures. Okay, I will take rectangle, all these things. The derivation of this centroid, it will be done by integration method. Suppose this is a rectangle. How we will calculate the centroid? It will be taken a strip, then we will use the formula for x bar, integration of x dA divided by integration of dA. By that, taking in a strip, single strip, and doing integration, we will be getting the x bar. Then from this one you will get x bar, from this axis you got y bar, you got x bar. Similarly, okay, this is the actual way. So you don't need to go into derivation. So I will just write the formula for simple plane figure. See, and remember this. The first figure I am taking, this is a rectangle. Okay, Then another figure I'm taking, another figure like a circle. Okay, then I will take a triangle. Okay, then we will take some more figure like, okay, this is the half of this circle. Then we will take a quarter circle, 1/4 of the circle. So this one. Okay, now I'm taking another circle. This is the 1/4 of the circle. Okay, so these are the sum of the normal formula. Another will be square. Okay, these are the simple. Then we have other like parabola, hyperbola, parabola. For that plane figure also we can calculate centroid, but that will be not in our case. Okay, so suppose this is the centroid location. Here is the centroid location. Suppose here is the centroid location. I'm drawing like this. Okay, these are the rectangle. This is the circle. This is the triangle. This is the half of the circle. This is the quarter of the circle. This is a square. So I'm taking, this is the length called b, then height h. Here having a diameter of this circle, this is the diameter. Suppose this is the diameter, how much? Diameter is d. Here having height of this triangle is equal to h, the base is equal to b. Again here is the d, here is the d by 2. This one is height of this half circle is d by 2. Here is the total d. Okay, here is again I will take for square, the same formula will be applicable here, a. Okay, you don't need the square, the formula of the rectangle will be applicable here in the square. So area क्या है इसका, ये जो rectangle आर area कौन हम जाने चाहिए, area is equal to b into h. आर area कौन ना पाई आर स्क्वायर, ना मुझे लिखिपारि पाई इंटू आर को जदि डी रे लिखिबी डी बाई 2 पाई डी स्क्वायर बाई 4 पाई बाई 4 डी स्क्वायर. एटार कौन हाफ इंटू बेस इंटू हाइट आर एरिया. एटा कौन पाई डी स्क्वायर और आई कैन से पाई आर स्क्वायर. ठीक है, जहाँ भी हो डी टर्म रे देछि बोली पाई बाई आर अधा कौन हम पाई डी स्क्वायर बाई 4 डिवाइडेड बाई 2. सो एटार एरिया केते हबो ना सर्कुलर एरिया डिवाइडेड बाई 2. एरिया विल बी पाई डी स्क्वायर डिवाइडेड बाई 4 अच्छी डिवाइडेड बाई 2 हेल्ले 4 दुगुणे 8 हो. एटार कौन हम एरिया इज इक्वल टू पाई डी स्क्वायर डिवाइडेड बाई ये 4 थिला आउरी 4 भाग करार अच्छे. सो 1/4 ऑफ द सर्कल. सो 4 चौकु 16. ठीक अच्छे, एटा हला एरिया. ना मु कौन कहूँ सब ए पॉइंट नेली, एटा गोटे पॉइंट मु सब कैलकुलेट करी, मोर है रेफरेंस ए पॉइंट. ठीक अच्छे, कौटू मु कैलकुलेट करी. सपोज मु ए पॉइंट रु ए एक्सिस रे काढिली, एटा हला एक्स बार. से पॉइंट रु ऊपर काढी एटा हला वाई बार. ए पॉइंट रु एटा हला आर निजे सेंटर. ओके, एटार मु ए बेस रु नेली हाउ मच एक्स बार. ठीक अच्छे, आ एठरू एटा हला बेस, एटा हला एपेक्स ऑफ द एपेक्स रु केते हो एड्ज रु माने ट्रायंगल रो एड्ज रु. हियर एडू केते हो, एडू केते हो, एडू केते हो, ए सब कैलकुलेट करबा. ठीक अच्छे, केमिति कैलकुलेट कर आर फार्मूला सब देखि दियो. आर एडार हबो b बाय 2, एक्स बार डा केते हबो b बाय 2, y बार डा केते हबो h बाय 2. सो x बार इज इक्वल टू नथिंग बट b बाय 2, y बार इज नथिंग बट h बाय 2. ठीक है ना. सेंट्रॉइड एटा हला 0 0 लोकेशन मु आकु नै गली, ताले सेंट्रॉइड कोड लाई करियो से जगह. सो x बार केते नेली 0, y बार केते नेली 0. ठीक अछि. नाउ फॉर दिस वन you have to take a strip, then you have to do the integration about this axis only. So after that you will get the answer like this. Base ru ए जो centroid location तल पटु देख तले बहुत एरिया अच्छे, ठीक अच्छे। सपोज ए हाइटा है एच, ठीक अच्छे, तले बहुत एरिया अच्छे माने एपटे ए पाखापाखि तल एरिया आड़ी कनसेंट्रेट हम कौन सीजीटा कि सेंट्रोइडटा। सो एटा नियरली ए जो h/2 सपोज एडा है h/2, ठीक अच्छे, से तले लाई कर एडा है h/2 ता तले लाई कर एडा केते कहंती ना एडा पाखापाखि 1/3 हम से हम 2/3 ऊपर डिस्टेंस माने 33% तल पटू 66% ऊपर पटू। सो एडा हम 2/3 ऑफ द हाइट ऊपर पटू हम 2/3 सॉरी 2/3 ऑफ द हाइट ए डिस्टेंसटा केते हम ए डिस्टेंसटा हम ना 1/3 ऑफ द हाइट h/3। देखो ट्रायंगल ये गोटे मन रखा पड़ो, यहाँ गोटे ट्रायंगल आर बेस रु पाखारे बहुत एरिया अच्छी ए पाखापाखि सेंट्रोइड लाई कर तल पटू हम 1/3 माने एच री भाग ऊपर हम 2/3 2/3 ऑफ एच। यहाँ फर्मूला कौट बेस रु ए जगार ए हाइटा केते हम जिते बड़े भी तुम देखुच कौन सर्कल है ए प्लेन एड्ज रु सब जिते प्लेन एड्ज रु केते डिस्टेंस रहियो ना 4r/3 पाई, ठीक है। एटा कौन y कोऑर्डिनेट, x कोऑर्डिनेट कौन मुझे नहीं जी ताकू एटा हला हमरो कौन हमें एटा नहीं छी ना 0 0 ए जगह आम कैलकुलेट कर एक्सिस यू स्टार्ट है माने ओरिजिन ऑफ द एक्सिस एटा हला सेंटर। सो ए जगह एटार केते हबो डिस्टेंस एमदी समान 4r/3 पाए ए डिस्टेंस से भी हाइट भी केते हबो 4r/3 पाए, ठीक अच्छे। ये सेंट्रोइड रु एठू एति डिस्टेंस केते हला सब मु कह दोसी एठू एति केते ना तार अधा b/2 ओके एठू एति केते h/2 एठी तो सेंट्रोइड लाई करूची, ठीक अच्छे। एटा तल पटू केते 1/3 h/3 ऊपर पटू 2h/3 ए जगह ऊपर केते ना 4r/3 पाए, ठीक अच्छे। ए जगह एठी केते 4r/3 पाए एठू ऊपर केते 4r/3 पाए। सिमिलरली एटा केते हबो ना एटार लेखिया कौन दरकार एटार आर अधा हम a/2 ठीक अच्छे। x बार हम a/2 y बार हम a/2 एरिया हला आर कौन एरिया हला a², ठीक अच्छे। बर्तमान ये सब फॉर्मूला है आमर नॉर्मल प्लेन फिगर। बर्तमान मुझे केतटा हॉलो फिगर कर, ठीक अच्छे। ये स्लाइड रे रखा को चेष्टा करिया। सो नाउ आई एम जस्ट जूम आउट। सो बेसिक एटा थिला हमर y बार, ठीक अच्छे। ये जगह y बार एटा थिला x बार y बार, ठीक अच्छे। ये सब कैलकुलेट करदे नॉर्मल। बर्तमान मु कौन करुँची आउ फिगर नौ मते एतिकी हेले एग्जाम सफिशिएंट, ठीक अच्छे। बर्तमान कॉम्प्लेक्स केतेटा डायग्राम नवा तार केमि सेंट्रोइड कैलकुलेट हम को फॉर्मूला यूज करी x बार इक्वल टू केते y बार इक्वल टू केते ए फॉर्मूला यूज करी आम कैलकुलेट करिया। देखो एटा प्लस माइनस सब हो पारे जदि गोटे आड कर बहुत सारा एरिया अच्छे आड कर जदि को एरिया को सब्सट्रैक्ट करार अच्छी ये तुम नहीं कौन माइनस भी नहीं पार ये माइनस भी नब जदि गोटे बड़ एरिया छोट एरिया को सब्सट्रैक्ट करार अच्छे, ठीक अच्छे। किंतु टोटल एरिया सब लाइक सेमती हम प्लस माइनस जहाँ भी सिचुएशन अनुसार आम देखा। एग्जांपल मुझे देवी। सो वेरियस कॉम्प्लेक्स सेक्शन केमी सेंट्रोइड कैलकुलेशन करा बर्तमान मुझे एग्जांपल नौ। लास्टली आउ गोटे फिगर जदि सेंट्रोइड फॉर्मूला मुझे तुमको कहबी यहाँ हल गोटे ट्रापेजियमटा आर एरिया फॉर्मूला कौन हाफ इंटू पैरेलल साइड रो सम a प्लस बी इंटू हाइट ए एक्स फॉर्मूला माने जोटा जो एड्ज रु तुम कैलकुलेट कर तार फॉर्मूला केमी हम देख सेंट्रोइड एटा एमती हम एक्स फॉर्मूला लिखुच कौटू ए बड़ एड्ज रु लिखुच माने बी पाखर तुम लिखुच ताने तुम लिख अपोजिट एड्ज रो 2 टाइम्स एरिया प्लस तल एड्जटा बी डिवाइडेड बाय सम ऑफ ए प्लस बी इंटू 1/3 of the height h/3 एटा हो x y रो सेमिति जदि लिखिबो y रो केमिति हो ना a ठु लिखुछो कोठु a रू लिखुछो तो 2 times b लिखियो 2 times b plus area divided by a plus b into h/3 एटा हला गोटे फार्मूला ट्रापेजियम रो सेंट्रोइड काढिया पय गोटे एड्ज रो ठीक अछि actually there will be no question from trapezium but still you should know the formula now ए गोटे हला गोटे hollow rectangular section ठीक अछि एटा सॉलिड सेक्शन अछि ए पार्टटा hollow हो जाय माने गोटे होल करा जाय वर्तमान ए सेक्शन रो केमिति हमें कैलकुलेट करिया सेंट्रोइड सेंटर ऑफ ग्रेविटी तुम जहा कहचो सेंट्रोइड तो एरिया नहीं केम करिया वर्तमान सपोज एटा हला b टोटल हाइट टा हला h मार थिकनेस टा नोची सपोज t हलार थिकनेस मु केमिति काढिबी अरे सेंट्रोइड टा देखो सेंट्रोइड रो x बार काढियार अछि टोटल बड़ फिगर टार एरिया हला सपोज a1 छोटो डाई आर हला एडा रहला a2 मु सपोज एमिति ने मु कोन करिवि x बार a1 x1 करो a1 ठीक अछि a1 एरिया x1 माने a2 x बार एरिया रो ए जो छोट बड़ एरिया रो सेंट्रोइड x केते हो आर बड़ एरिया रो सेंट्रोइड एठी हो b/2 प्लस 8 प्लस नहीं सब्सट्रैक्ट करियार अछि कम बे होलो सेक्शन एरिया टा ऐड हेनी सब्सट्रैक्ट हेची माइनस एरिया सेकंड एरिया a2 इनटू आर x केते एक्सिस रो एडा हला ओरिजिन मुनेछि एठू केते हो x एडा भी हो b/2 डिवाइडेड बाय टोटल एरिया केन देबो ना कैपिटल एरिया माइनस स्मॉल एरिया a1 माइनस a2 वर्तमान एडा यूज जदी करबो कोन हो a1 प्रथम हेची bh माइनस a2 कोन a2 रो एरिया हला थिकनेस इनटू विड्थ इनटू b/2 कॉमन नै जाई बाहर तळे हला एरिया केते bh माइनस tb ठीक अछि वर्तमान एडा कैंसिल हो x बार हेला b/2 त माने b/2 समान b/2 रे एडा हला x बार सेमिति y बार जदी सेम फार्मूला यूज करी काढिबो टोटल सपोज एटा हाइट थिला केते h सो वर्तमान ए जो h/2 ठीक अछि इन कॉम्प्लेक्स फार्मूला रे एमिति जेते भी कॉम्प्लेक्स सिचुएशन थिवो तार x बार y बार हमें सेंटर लोकेशन आराम रे काढ पेरा सपोज एडा हला a एडा हला a मु एस छोटोडा रो कहूजी b साइड गुरा वर्तमान x बार आ y बार तमे निजे कैलकुलेट कर ठीक अछि सिमिलर फार्मूला पकेबो प्रथम एरिया रो a1 प्रथम एरिया रो एरिया a1 x1 कोन x1 हला ना प्रथम एरिया रो सेंट्रोइड a2 हला छोटो एरिया a2 तार सेंट्रोइड x2 जदी एरिया टा मिसी थांदा वर्तमान आउ केतेटा फिगर नै जिवा सी आई हैव ड्रॉन सम फिगर विल कैलकुलेट सेंट्रोइड एमिति किछि फिगर अछि सपोज कैपिटल डी हला बड़टा रो डायमीटर छोटोटा रो स्मॉल डी ताले फार्मूला x बार रो केमिति ना तमे कोन करो एडा होलोटा ठीक अछि एडा गोटे होलो सिलिंडर ता माने तमे कोन करो कैपिटल बड़ो ए रो करिवो a * x a1 x1 माइनस छोटो रो एरिया a2 * x2 छोटो रो सेंट्रोइड डिवाइडेड बाय a1 माइनस a2 एमिति गले x बार रो फार्मूला बाहर पड़ो कॉन्सेंट्रिक सिदबे समान जगह रे बाहर 0 बाहर ठीक अछि स्टिल फार्मूला में यूज कर पेरा धर एडा हला a1 एडा हला a2 एडा हला a3 ए पॉइंट हला मु नेले ओरिजिन सपोज एडा हला गोटे पॉइंट r सेंट्रोइड रो एडा हला पॉइंट सेंट्रोइड रो r हला एडा सेंट्रोइड टोटल सेंट्रोइड रो फार्मूला x बार पकेबा a1 x1 प्लस a2 x2 प्लस a3 x3 डिवाइडेड बाय एरिया सब रो छोट छोट रो कैलकुलेट करिया समस्त को डायमेंशन दे दियो ठीक अछि जते भी डायमेंशन अछि कैलकुलेट करिया a1 प्लस a2 प्लस a3 y बार दरकार y बार सिमिलर फार्मूला होगा a1 y1 a2 y बार रो फार्मूला माने सपोज एठी कोडी रहइबो माने एटा तो रहइबोनी कोडी ऑन द प्लेन फिगर रहइबोनी आउटसाइड द प्लेन फिगर एटा गोटे एग्जांपल हो ठीक अछि where you can prove that the centroid is not mandatory to be lie on the plane a2 y2 plus a3 y3 divided by the sum of area like a1 plus a2 plus a3 similarly see these are the formula here is the a1 a2 a3 you can calculate x bar y bar here is the symmetric I a1 a2 a3 or you can say 2 times these are given so here will be the centroid I will take the origin over here then I'll calculate, take an origin over here. Here is the 2 area, a1, a2. Similarly, for all the case, x bar, y bar can be calculated very easily. Here is some formula, some another figure, like here will be the area a1, this one will be a2. So from the down, it's, we know for x1, suppose this is the, I'll take as the centroid. Okay, we'll take, this was not as center, we'll take another. Here is the, suppose the center. According to this point, we will calculate all this. From, for triangle, the area is 2h by 3. Here is, we know, suppose this is d, so it is 4r by 3 pi. Suppose this is the center. For this one, we will calculate the same, a1 x1 minus a2 x2. A is the area of this half circle, then the total circle is the trapezoidal area minus small half circle area will be x bar. Likewise, we can calculate a y bar. For all these cases, we can do all our calculation. So this is all about the concept behind centroid. You just need to remember these two slides. This one, sorry, this one, the formula for different simple figure. So you can, for no need to remember this one, you can just see and say. Here in, for triangle, you have to remember from the base, it's h by 3. It will be, because the centroid of this triangle will lie towards the base, so 1/3 of the height, upper one 2/3 of the height. And here is the formula you should remember, then all the question of centroid will be easily calculated. So these are the different formula section, you can calculate for that. So thank you for watching. In the next video, we will discuss all the other chapter. For slide, do join our Telegram channel so you can get the lecture slide. Okay, thank you for watching.